Have you ever pondered the profound question, do multiverses exist? And if so, how do they interact with our universe? This intriguing question has been the subject of many thought-provoking debates and discussions among physicists and cosmologists worldwide. The concept of multiverses, a cosmos teeming with an infinite number of universes, including our own, is not a mere flight of fancy. It is rooted in advanced scientific theories. Quantum mechanics, for instance, with its wave-particle duality and superposition, suggests the possibility of multiple realities. String theory, with its 10 or 11 dimensions, proposes an array of different universes. And cosmic inflation, a theory that explains the exponential expansion of space following the Big Bang, hints at the existence of an infinite number of bubble universes. These theories provide a fascinating canvas on which we can paint our understanding of multiverses. So let's dive into the realm of theoretical physics to explore these fascinating questions. To comprehend the concept of multiverses, we must first grasp the basics of quantum mechanics and string theory. Quantum mechanics, in essence, is the study of the very small. It's a branch of physics that deals with particles at the quantum level, including atoms and subatomic particles like electrons and photons. Quantum mechanics tells us that these particles can exist in multiple states at once, a concept known as superposition. Imagine this. You are in your room, but at the same time a version of you is also in the kitchen. Sounds baffling, doesn't it? Well, that's the magic of quantum mechanics. Now, let's move on to string theory. While quantum mechanics deals with the very small, string theory is a theoretical framework that aims to reconcile quantum mechanics with general relativity, the theory that explains gravity and large-scale phenomena. In the world of string theory, the fundamental particles we know, like electrons or quarks, are not zero-dimensional points. Instead, they are one-dimensional strings. These strings vibrate at different frequencies, and these vibrations give the particles their unique properties. What's more, string theory suggests that our universe isn't just the 3 dimensions of space and 1 dimension of time that we can perceive. There could be as many as 10 dimensions, most of which are compacted to a size far beyond our ability to detect. So, how do these theories relate to multiverses? Well, quantum mechanics, with its superposition, suggests that there could be multiple outcomes to every situation, each occurring in a different universe. Meanwhile, string theory, with its extra dimensions, hints at the possibility of universes beyond our perception, existing parallel to ours. This brings us to the concept of parallel universes, universes that exist alongside ours, each with its own laws of physics, its own history, and maybe even its own versions of us. Now that we have a fundamental understanding of these theories, we can delve into the concept of multiverses. The multiverse theory, as the name suggests, proposes the existence of multiple universes, including the one we inhabit. It's quite an intriguing concept, isn't it? According to this theory, our universe is simply one tiny bubble in a vast cosmic ocean filled with an infinite number of other bubbles or universes. This idea of infinite universes is based on the principles of quantum mechanics and string theory. The theory suggests that our universe is not the only one, but one among an endless array of universes, each with its own laws of physics, dimensions, and realities. To understand this better, let's delve into the types of multiverses proposed by physicists. We have level 1, level 2, level 3, and level 4 multiverses. Level 1 multiverse is based on the concept of infinity. It proposes that space is so large that it has infinite pockets of universes, each mirroring our own with slight variations. Level 2 multiverses, on the other hand, propose that other universes exist in regions of space so far away that light from those universes will never reach us. These universes may have different laws of physics and different constants of nature. The Level 3 multiverse is a consequence of the many worlds interpretation of quantum mechanics. It suggests that every possible outcome of every event defines a different universe. Lastly, Level 4 multiverse, the most abstract, encompasses all universes that can be described by different mathematical structures. It proposes that every mathematically possible universe exists in some reality, so we're living in a cosmos where an infinite number of universes exist, each with its own unique laws, dimensions, and realities, and we're just a tiny part of this vast multiverse. It's quite a humbling thought, isn't it? The idea of multiple universes is mind-boggling, isn't it? But how do these multiverses interact with our universe? If multiverses do exist, a burning question arises: how do they interact with our universe? To address this, let's turn to the theories proposed by physicists. One dominant idea is that of bubble universes. Imagine our universe as a bubble floating in a cosmic ocean of other bubbles, each one a separate universe with its own laws of physics. These bubbles could potentially interact or even collide, leading to a transfer of energy or matter. But let's delve deeper. Consider the concept of quantum entanglement, a phenomenon where particles become interconnected, sharing states instantaneously no matter the distance between them. Einstein famously referred to this as spooky action at a distance. Now, what if this spooky action could allow for interaction between parallel universes? In the world of quantum physics, particles can exist in multiple states at once. It's only when we observe them that these particles choose a state. This is the basis of the famous Schrödinger's cat thought experiment, where a cat in a box is both alive and dead until observed. Some physicists propose that each possible state of a particle corresponds to a different universe. When we observe a particle and collapse its many possibilities into one outcome, we are merely interacting with one of many parallel universes. Moreover, if quantum entanglement can link particles in our universe, could it not theoretically link particles across different universes? This would imply a form of interaction between multiverses, where actions in our universe could have ripple effects in others. However, it's crucial to note that these concepts are highly theoretical and speculative. The interaction of multiverses is not something we can directly observe or test with our current technology. It's a frontier of physics that challenges our understanding of reality. We can't definitively say how multiverses might interact with our universe. The theories we've discussed are just that, theories. They offer tantalizing possibilities, but until we have empirical evidence, they remain unproven. The interaction of multiverses is still a topic of ongoing research and debate among physicists. The concept of multiverses, if proven, has profound implications on our understanding of reality. It's a notion that doesn't merely add a new layer to our perception of the cosmos, but fundamentally alters the fabric of our comprehension. Let's delve into this. For starters, the multiverse theory could redefine our concept of reality itself. If multiple universes exist, each with its own set of physical laws and constants, what we perceive as real and concrete might be entirely different in another universe. Our reality, therefore, could be just one of countless realities, each as valid as the other. Next, let's consider time. In our universe, time is linear, moving from the past to the future, but in a multiverse, time could operate differently. It might not be linear, or perhaps not exist at all. It's a concept that challenges our understanding and experience of time, suggesting that our perception of it is merely a construct of our universe. Now, think about our place in the cosmos. We've always considered ourselves unique, special. But if the multiverse theory holds true, there could be an infinite number of universes with life forms identical to us, living out different versions of our lives. It's a humbling thought, isn't it, that we may not be as unique as we've always believed. And then there's the question of determinism versus randomness. If every possible outcome of every event is playing out in some universe, does that mean our lives are predetermined, or is it all just random? It's a philosophical conundrum that has implications on how we view free will and fate. Finally, the multiverse theory could have significant implications for the field of physics. It could answer questions about the fundamental nature of particles, the origins of the universe, and the mysteries of dark matter and dark energy. The multiverse theory, while not yet proven, continues to challenge and expand our understanding of the universe.